Hello guys and welcome back to my YouTube channel. In today's video, we shall be looking at human in the loop. So human in the loop is the when a human feedback is needed for an agent to decide the next step to take or before it completes a particular task. So understand it this way that maybe there is a running graph. All right. So and at some point it's for safety and more accuracy, it needs a human approval or input to actually complete a particular task. All right. So this is when a graph is running and it requires a human to give a feedback. So this is human in the loop. So we're going to look at it shortly and then how it actually works. All right. So we're going to initialize our LLM. We're working with shard Glock, loading our environment variable, and then initializing the LLM. We're using the OpenAI GPT OSS 120B model. So we run this cell, and as this cell is running, so in this tutorial, we'll be using a simple project. Now, the simple project will be taking few steps. So is is an agent that will be executing a task for you. All right. So, but before it executes a particular task, it's going to first of all write down the outline of the task it will execute before it goes into the next node, which will now execute the task. All right. So, what we want to do is when we invoke the agent, it's going to produce the outline of that particular task we want it to execute, whether it's a programming task or a writing task. All right. And then we are going to request for a human feedback, whether the outline is good, whether the human wants to make an input into the outline, or it should just go and then execute the task. So that is what we are going to be doing in this project. So we'll look at it step by step and how it is being achieved and how the human in the loop comes in. All right, so this is our state schema. We'll have different keys. The user input, this is the input that the user will give to the system. The outline, this is the outline that the first agent that lists the outline will produce. So this is the feedback, which will be a text. And whenever a feedback has been given, this feedback will become true. So when the feedback has not been given, it will be false. All right, then this key holds the next step that we want the agent to execute. All right, whether I want the agent to continue or to revisit or to end. All right, so that is what this key will be holding. And then this key will now hold the completed task, whether it's a programming task or a writing task. So this is our state schema. Then we have some other pedantic schemas here, which are the feedback schema and the outline schema. So this will be the schema for processing the feedback from the user or from the human. All right, so after it gets the feedback from the human, it checks to know the human's intention, whether the human wants to continue, revisit, or end. All right, then this is for the outline, which will produce a list of strings. So we're going to run our schema. All right, now let's look at our prompt. We have several prompts here. The first prompt is the prompt to list the outline, all right, which is telling it first of all, role based, you're a planner agent. Your task is to generate clear structural outline about a particular task, and then the rules you should generate the task on, and then how the output should be. And then we will be passing the schema. All right, this schema is the structure of how we want the output of this agent. So we'll be passing this schema here. So this will now be telling this agent, this is how we want this task to execute. So this is what I mean. All right, to pass this schema, we're going to be using, so let me take this outline schema as an example. So to pass this schema, we're going to say outline schema, the model JSON schema. So when we pass this there, it's going to generate the complete schema, all right, and how each key and the type of data each key is holding. So this is what we are going to be passing to the prompt. so that the LLM will understand the structure of the schema. All right, so now this other prompt is to execute the task. All right, so you are an executor which takes the task and then the approve execution outline, so which is the outline, and then it takes the task from the user, which was the input message from the user. Then this prompt is to manage the feedback from the user. All right, so when the user gives a feedback, so it takes the feedback, it now decide whether the user wants to continue, revisit, or end. All right, so we'll pass this feedback to this prompt and also the schema for the feedback. Remember, we'll have a schema for the feedback here, which is this feedback schema. And then the last not the least, the outline prompt one. Now, when a user gives a feedback and the feedback is revisit, all right, so we are going to revisit that particular outline and regenerate the outline. But we're not going to do that in blind to the formal outline that was executed. That is the essence of this other prompt here. So when you watch the instruction, it says that you have already generated an execution outline for the task. A human reviewed and approved feedback on that outline. So your task is now to update the outline, giving it the rules, the output format, and then these are the data it takes. It takes the task, which was the original task that was given by the user. It takes the outline. The outline it has already generated. It takes the current feedback from the user so that it knows what it needs to add to the outline. And then the type of data it needs to return, which is the schema for the outline. Now, it's taking the task because it needs to know what the user actually wants to develop, what it has done, and then the feedback from the user. So these are just the prompts. All right, so we build our structured LLM. We need the structured LLM for the outline and the structured LLM for the feedback because they have a structured output. All right, then let's now build the graph. Okay, we're importing our human message system message for LangChain call.messages, LangGraph.graph. We import the start, end, and state graph. Then we'll be importing memory from checkpointer.memory and then the display for displaying the compiled graph. All right, so I have 3 nodes here. So we shall be looking at each of these nodes one after the other. All right, so the first node is the outline node. So this node writes the outline. Okay, it writes the outline. So for this node to execute, we have 2 conditions. One is either the user has given a feedback or the user has not given a feedback. So this node needs to know, has the user given a feedback or has the user not given a feedback? All right, so that's why the first thing it does is to get feedback from the schema. So if feedback has been set, it picks it, but if feedback has not been set, it takes false. That means a feedback has not been given yet. All right, so now check. If feedback means if a feedback has been given, that means he's going to be working with the outline prompt 1. All right, to working with the outline prompt 1 to constitute the system message. So the outline prompt 1 dot format, we are now populating all the values that we have, which are the tags, outline, feedback, and schema. All right, so the tags is the first user input from the states. The outline is the outline that has been generated earlier, and then the feedback was the feedback, which is the feedback text, the feedback from the user, and then the schema, which is the outline schema, the model JSON schema, to have a structure of how the schema should be. So that is the system message. So we are not populating any human message here because every instruction is already inside the system message. So we are now invoking our LLM. So the response is outline LLM.invoke. We are passing this message that we have constructed here, and then the LLM will give an output. Remember, this output is given is a type of outline schema. All right, an outline schema has one key, which is outline. All right, so we are populating the outline with response.outline. All right, so but this is if there has been a feedback. Then if there has not been a feedback, then it uses the first outline prompt, okay, which has only one value that we need to populate there. All right, so we format and then add it, which is the schema, which is the outline, the model JSON schema. All right, and then we constitute our human message, which is passing the user input here now. All right, and then the response will now be outline llm.invoke. We are passing both our system message and human message, and then we update the state. So this is how the outline node works. Right, this is the feedback node. All right, so the feedback node is the node that takes the human feedback and then processes it to decide the human intent. All right, so we get the system message first, which is taking the feedback prompt, formatting it, and then populating the different values there, which are the feedback and the schema. The feedback is taking the human feedback, and then the schema is taking the schema structure. All right, and then the human message is now we're telling it decide the user feedback, decide what the user wants, which is supposed to return either continue, revisit, or end. All right, so we now say response.feedback llm.invoke. We are passing both our system and human message, and then we remember that this feedback LLM is a structured LLM from feedback schema. All right, and feedback schema has one key, which is next step. So we are populating next step with the value we got there, and then we are populating the feedback with true because a feedback has been given. All right, so we are updating the feedback with true because a feedback has been given. Then let's go to the execution node. The node that is supposed to now execute the task is still very straightforward. All right, so we constitute the system message, which takes the execute prompt and then update all the values we have there, which include which is the outline. All right, so the outline, we are updating it from the outline we have in the state and then passing the human message. The task is we now pass that initial task that the user passed to the system. All right, so let me add this. So we now pass the initial task that the user passed to the system, which was in the user input of the state. So when we now get this message, we will now pass them to the LLM. Remember here we are using the LLM because we don't need any structured output, we just need a raw output from the LLM. So we're invoking and then we are passing the system message and then the human message. All right, and then we know that this response is a type of AI message, so we are now populating the task, which is the key to hold the completed task, with response.content. So that is it for the execution task. Then we need a node to decide the next node to execute after the feedback. All right, so we need to run a conditional node, so which is what we defined here. So this conditional node will return either continue, revisit, or end. All right, so it takes this key, the next step from the state. And we know that this next step from the state, according to our schema, can only hold three values. It can hold either it holds continue, revisit, or end, according to what it returned from the feedback node. So what we are doing here is whatever it is holding, we should return it. And we know it should either be continue, revisit, or end. All right, so that is what this decision node will do for us. Now, let's go over to build the graph. All right, so this is where there is a little bit tricky that we also need to look at, and then we understand what actually happens. All right, so first of all, we define an instance of the state graph passing our state schema as state schema. So remember, we're working with state schema, and then we add all our nodes. Remember, when you're adding node, you don't need to add the conditional node. All right, so we'll add it while building the conditional edge. We'll get there. So we add the outline node, we'll add the feedback node, and then we'll add the execute node. Now let's build the graph. All right, so from start we get to outline. All right, so when outline is done executing, we'll go from outline to feedback. All right, then from feedback, we are after a feedback has been given, we are passing a conditional edge. That's why we have a conditional edge that will go from feedback to that conditional edge. That means once this node is executed, the execution should come to this. All right. So this conditional edge, which is the decide node, is either it returns continue, revisit, or end. So what I specified here is if it is returning continue, go to execute. Remember, we have execute here. That means the user wants to continue and execute the task. If it returns revisit, that means the user wants the outline to be revisited again. Then go to the outline node. If it returns end, end the graph execution. All right. So we'll now what we now need, because if it's going to continue, that if it's going to outline, that means it will still go from outline to feedback and still come here again. But if it is going to execute, we need to go from execute to end, and this is just to go to end. All right. Then we are building the memory. All right. So because we need to add memory to it, and then this is the interesting part that we tell it where we want the feedback to come in. All right. So while we are compiling the graph, all right, so we pass the checkpointer and then we'll say interrupt after. So I want it to be interrupted, I want the agent to be interrupted after it has executed the outline. All right, I want it to be interrupted. So why passing this means that we are telling this agent where you are executing, all right, once you get to outline, stop, don't continue. So once you have executed outline, interrupt after, and we're passing outline. So once you've gotten to outline, stop execution, because something is going to happen. So at that point, we need to update the state of the graph before it can actually continue. All right, so now let's build this graph and let's look at it, how it looks like. All right, so this is our graph now. So remember, it's going from start to outline, and we are having an interrupt when this outline is done. So that means once this outline is executed, it's going to stop here, and we'll now pass a feedback before it goes to feedback. All right, and after feedback, when you look at all these lines showing that there is a conditional edge that was added to decide whether we are going from feedback to execute. Once it returns continue, we should go to execute, or whether we are going from feedback when it returns revisit, we should go to outline, or whether we are going from feedback when it has end, we'll go to end. All right, but if it comes to execute, we should now go to from execute to end. So this is just quite a structured graph. So if you fully understand how this works, then there are so many things you can tweak comfortably while building your graph. All right, then let's go over to execute some functions. So we are defining our config for the thread. So we are passing the thread ID as 1, 2, 3, 4. All right. So then this is the instruction we are passing to the graph. So we say write a full backend code for me using fast API that has sign up, login, logout, get user detail with JWT token and email verification using OTP. All right. This is quite an extensive instruction, and then we are passing this to the agent so that it will execute this. Then we're now saying result is equals to agent.invoke. We are passing the input. All right, so we are populating the user input key, and then we are passing the config. All right, so let's run this code. So this code is done running now. So let me show us something now. Let's look at what we have at the result. So let's look at what we have at the result. Oh, this was wrong. Okay. All right, so at the result, when we look at this, we see that we only have two keys that has been populated, which is the user input and the outline. So these are the list of the outline that it gives us. All right, so let's now look at the outline. So these are the outline. This is the first outline, second outline, third outline, how it can actually execute this. All right, so listing everything from A to Z, what it's supposed to do, both from setting up the fast API projects and all that. So now we can get the agent state to know the graph state to know where the graph is at that particular time. So if we run agent.getState and we're passing the config, passing this config is to know the thread we are trying to get the state, and then we are passing next. Dot next means what is the next node you are supposed to execute. So if I run this now, you see that it's showing me that the next node that this agent is supposed to execute is the feedback node. Now, if this agent is completed, we're not going to get any value here. So it's telling me that this agent, the next node is supposed to execute is the feedback node. All right, so that's the next node is supposed to do or to execute. So what we can actually do is to now update this graph, to update the state, and then it can continue. Then I want to point out something to us. All right, so remember that at the end of each of these nodes, using this return function, what we are doing here is that we are updating the state. All right, so and while this graph is running, the only place that you can update the state is through this return function. You can't update the state inside the node. Is why it is a returning data that you can update the state. And then another way you can update the state is if the graph is running and then you need to update the state using this method agent.update state. That is the only way you can update the state. So to update this state, we are getting a feedback. So this is the feedback. I also want to deploy the app on render, capture it as well in the outline. So it should capture in the outline how this app can be deployed on render. And then I'm updating the state. So to update the state, you say agent.update state. Remember, you are passing your config so that it knows the thread it needs to update. All right, so it knows the per exact thread it needs to update, passing the values. All right, so the values I want to update is the feedback test. Remember, the feedback test is a key in our schema, and we are passing this feedback. Okay, and we are telling it update this as the outline node, as node equals to outline. So we are telling it to update this as the outline node. Update it like it was the outline node that was actually updating this. Remember that the outline node was the last node that was executed. So we are adding a feedback at this level now before we are coming to this. So we are telling it update this like it is this outline node that is updating it, so that the update can actually go in seamlessly into the agent. All right, so that is what we are doing here. So we run this so that it can get the update, and it has gotten the update. Then if we have updated, to now continue running the agent, you can say agent.invoke. Then in the input, you need to pass nothing. You need to pass none. All right, so that it knows that, okay, this is a continuous node, and then we are passing config. All right, so which to tell it, okay, this is the thread we are running with. So we can run this. Oh, we'll have some errors here. So why this error? Let me run this again. All right, so it's successful now. I don't know why the error occurred the first time. All right, then let's now look at the result that we'll have. All right, so when we look at the result, you see that we already have some other keys populated. We're having the feedback test, the feedback, and then the next step. All right, so the feedback has the data we added as a feedback, and then we now see that feedback is now true because there has been a feedback, and then the next step was revisit. All right, so the next step was revisit, so that was why it revisited. And when we check the outline, you see that it has added a deployment step for render here. So that means that the feedback that we gave was captured. All right, then let's go ahead to continue. So we are adding another feedback, which is saying go ahead and complete the task. All right, so adding the thread, updating the feedback key, and then passing it as updating it as the outline node. So we'll run this, and then we'll invoke the agent. All right. All right, so that means our agent is done running now. So if we print the result, we see that the task has been here. All right, and when we look at next step was continue. That was why it was able to continue and then execute our task. Okay, so if we print the task so that we can actually see the task that was executed, we'll see a well-structured work on what we wanted the agent to do. All right, so a complete ready to run fast API backend that can actually execute all these things. So this was the task that the agent executed. Now let's check one other thing. All right, so if we check agent dot get state and the config, so config, we are passing config, and then we are trying to get the next. All right, so we are trying to get the next node that was supposed to execute. All right, then if we run this, we'll see that nothing was returned because there is no node that is supposed to execute next here. All right, so because this agent has executed completely. Remember that when we ran this initially, when we were here, it returned feedback because the feedback was the next node that was going to execute. So I believe with this tutorial, you'll be able to understand how human in the loop works. So thank you very much for watching this video. If you enjoyed the video, subscribe to this YouTube channel, give us a thumbs up so that this video can actually get to others and they can actually learn the way you are learning. Thank you very much for watching the video. Meanwhile, keep coding.